Good afternoon, class. Welcome to another edition of the After School Math Program, sponsored by yours truly. So, today we're going to be talking about trigonometry and trigonometry's ratios, which we kind of touched on at the end of class today. So, first off, before I really get into this, I was kind of debating either doing this in a British accent or a really southern genteel type accent. So I want opinions on that tomorrow before we get started. But anyway, take good notes over this while we're going through it. But anyway, so we touched on the trigonometric ratios today. So you just learned what sine, cosine, and tangent are. We use these here spaghetti pieces to figure out exactly what that is. So after we got done with that, I introduced you to these ratios that we're going to talk about. Every triangle has them. It's the fact that the sine of an angle is just equal to the opposite side over the hypotenuse. So you got the sine of an angle is equal to, again, the opposite side over the hypotenuse of that same triangle. My cosine is just the cosine of an angle is equal to the side that's adjacent to it, so right next to it, and the hypotenuse. And then finally, we've got the tangent of x. He kind of stands out because he doesn't have anything to do with the hypotenuse. So the tangent of an angle is just equal to the opposite side over the adjacent side. So I showed you that today just in this form, SOHCAHTOA. So sine is the opposite over hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent angle. So that's my trigonometric ratios. So instead of just going in on about all of these little ratios, let's actually see it working. So bring up my next board. Hopefully won't break my spaghetti. Anyway, so this is my next board, and it's just talking about using trig. So we know what it is, we know what the ratios are, so let's actually use it. So in this case, I've got a ladder that's 5 meters long, and it's leaned against a vertical wall. That means that the building is normal. It's not, the Leaning Tower of Pisa or anything. It's a normal wall, straight up, straight down. And then it's leaned against that vertical wall at an angle of 65 degrees with the ground. So that's the angle it creates. So the three questions I'm going to ask. How high is the wall? How far is the foot of the ladder from that wall? And then what angle does the ladder make with that wall? Okay, so that's the three questions I'm going to ask. So I'm just going to move on to the work it out board, and we're going to work all parts of that out. So first step, every problem that you should be working is convert the word problem to something you know, and that for you guys is pictures, nice pictures. So again, we've got the 5 meter ladder leaned up against this wall, okay? And we're setting up our two different problems. So the first question was, how tall is this wall? Like how far up this wall does it reach? So I set that up, and what I'm looking for is the length of this wall to the point where the ladder reaches. So again, it made a 65-degree angle. That didn't change, and the ladder measure isn't going to change. That stays the same in both. It's just what I'm trying to find is different. So for A part, I'm trying to solve out for what this side is. I need to use sine, because what the sine of 65 degrees gives me is the opposite over the hypotenuse. So the opposite side to 65 is x over my hypotenuse, which is 5. So I pick sine because that's the two things I have and care about. Fine. So when I set up this equation here, I get the sine of 65 degrees is equal to x over 5. So I get that, and then I get this magical answer by I don't know how. Well, now you're going to learn how. Learning how means I plug it into this handy-dandy calculator. And if you look at what I have highlighted, that should be the sine of 65 degrees is equal to x over 5. And so what I just did was I multiplied the 5 over to get rid of it and get x by itself. What I end up getting is 4.53154, and it would go on forever, but I decided to stop at 2 digits. So that's the sign of that. So what that means is this wall right here is 4.53 meters high to the point where the ladder touches the wall. Okay? So that's what I was looking at for part A. Part B, I was trying to find out the foot of the ladder right here, how far it was away from the wall. So instead of my x being here this time, I moved it down here to find this length. So what that changes is I'm going to need to use the cosine of x, because the cosine gives me the adjacent, the side that's right next to my angle over the hypotenuse. So I just need to set up my ratios. Cosine of 65 degrees is x, which is my adjacent side, over 5, my hypotenuse. Just solve it out. Again, I'll get it highlighted on here. Type it in as such on your calculator. And all these can be found under Trig. We'll go over it tomorrow. So what I end up getting there when I multiply my 5 over is just 2.1309. I decide again to stop just with 2 digits, 2.11. That's 2.11 meters. Okay? The last problem was trying to make you use some kind of trig that I'm going to teach you tomorrow. But I wanted to show you that common sense beats all. The last question was just asking me that if I got that triangle that has a 65 degrees here and it's 90 degrees there, because again it's a vertical wall, can you find the other angle? Well, of course you can. Just take 180 degrees, subtract off the angles you already have, and what do you get? 25. That's the angle you're left with. So this angle up here has to be 25 degrees. That's what it's asking you for. So for tomorrow, I've got one more board. I want you to just kind of think about this problem. And again, I'll be introducing you to something tomorrow. I want you to try to figure out what that is between now and then. So this is my little think about it board. So if I give you a triangle with two sides and no angle besides the right angle, obviously we're talking about trigonometry, it's got to have a right angle. But if I give you a triangle with two sides and no angle besides that 90-degree angle, can you find the angle that I'm asking for? So what else might you need to know? That's the other question here. So this is kind of just an illustration of what I want you to think about. If I give you a triangle that I say has one leg that's 15 units long, another leg that's 6 units long, and I don't tell you what the hypotenuse is, first you need to think about how you're going to set it up to find this angle. So from this angle, I've got an opposite side and an adjacent side, so I need to use the tangent. This tangent gives me opposite over adjacent, so set up that ratio. My opposite side over my adjacent side, that's equal to my angle. So what I want you guys to ponder on tonight is how am I going to find and solve for x? Okay, that is the big question I want you to worry about tonight. Go ahead and make sure you take good notes over all this. Again, go back and watch me a couple times if you just get that bored or you miss something. And I guess I'll see you guys in class tomorrow. So you guys have a great night. See you in the morning, afternoon, whatever, whenever I have you. See you guys.